What's up guys, and welcome back to the Calculus Stories channel. Now in this video, we'll go ahead and focus on a topic that's usually presented in a pre-calculus class, and it is the topic of polar coordinates. So let's go ahead and jump right in. Now in this video, I'll be mostly concerned with showing you an example of how to achieve conversion between our rectangular coordinate points and our polar coordinate points. But before we go ahead and jump into that, let's go ahead and do a bit of a recap. So here I have an x and y plane and a point plotted out. Now, if you go ahead and remember from algebra, rectangular coordinate points is just another fancy word for saying the x, y system. Now, the first number that we have in our coordinate point right here represents the distance that you travel along the x coordinate line. The second number right here represents the distance that you travel along the y-coordinate line, and in this case we've traveled a distance of 4 units. And so plotting this point out, we get that its position is right here in the x and y plane. Now, when it comes to polar coordinates, we're talking about the same point in the same position, but our method of describing it changes quite a bit. Instead of relying on the x, y system, we're going to rely on two different parameters to go ahead and describe the position of this point in space. And so the two parameters that go into describing a polar coordinate is r and theta. Now, let's go ahead and go over them individually and describe what r and theta is. R is nothing more than a distance. A distance between what? A distance between where the point is located and the origin. And so we know that the origin is right here in the center. Now r is the distance between the origin and where our point actually is. And so let's go ahead and signify this distance with the letter r. And so that takes care of the first parameter. Now the second parameter is theta. Now, in this case, theta represents the angle measured counterclockwise from the positive x-axis. And so what that's referring to is this angle theta right here. And so by using these two parameters, r, which is the distance between the points and the origin, and theta, which represents the angle measured counterclockwise from the x-axis, we're going to be able to describe the position of this point in space. So now that we've been over that, let's go ahead and go into the topic of this video. In this video, we'll go ahead and go over an example of how to convert between these two coordinate systems. The rectangular coordinate system, or I'll just go ahead and refer to that as the x, y system, and the polar system, r, theta. And so symbolically, what we're trying to achieve is go from the x, y system and express this coordinate point in polar format. Now, to go ahead and achieve this, there's two equations that we're going to have to use. The equation to get r, which is equal to the square root of x squared plus y squared, and the second equation for theta, which is tangent of theta is equal to y divided by x. Alright, in our example, we're going to want to achieve conversion from the rectangular coordinate point 4, 4 to its polar coordinate r, theta. Now, to go ahead and start solving this problem, let's go ahead and choose an equation to work with to either find r or theta. And the one that I'll go ahead and choose is r, the simplest equation. And so we have r is equal to the square root of x squared plus y squared. And so plugging in what we know, we'll have the square root, and then we have x, which is 4 squared, plus y, which is 4 squared. And so let's go ahead and condense that even more. 4 squared is just 16 plus 16, and the square root of this. And so finally adding these two 16s, you'll get that r is equal to the square root of 32. In most cases, it usually happens that the answer that we get towards the end is the right answer, but it's not in its simplified form. And so what we want to go ahead and do right here before moving on to finding theta is to make sure that our R value is in its simplified form. Now, 32 is nothing more than the product between 16 and 2. Now, if you want to go ahead and check this, you can just go ahead and pull up a calculator and multiply 16 times 2, and you'll get 32. And so by going ahead and writing 32 as a product between 16 and 2, we can go ahead and use square root properties to go ahead and say that the square root of 16 times 2 is the square root of 16 times the square root of 2. And simplifying this further, the square root of 16 is 4, and the square root of 2 is a really long decimal number, so let's just go ahead and keep it as the square root of 2. And so this takes care of the first part, wherein we were trying to find R. Now, let's go ahead and use our second equation to go ahead and find what theta is. Let's go ahead and plug in what we know. We know y to be 4, and we know x to be 4 as well. And so once you go ahead and simplify this, you'll get that tangent of theta is equal to 1. Now, at this point, all we really have is a simple trigonometric equation. And what you have to do is rely on the unit circle to get you the answer for theta. Now, on the unit circle, this happens at 2 places. It happens at theta is equal to pi over 4, and at theta is equal to 5 pi over 4. So if there's 2 possibilities, how do we know which one is the right one? Well, we're going to have to use the question that was given to us as a clue as to what the correct angle is. And so the coordinate that we were given was 4, 4. And if you go ahead and look back, 4, 4 is a point whose position is found in the first quadrant. And so considering the angles that we have, our first angle is theta is equal to pi over 4, which lies in the first quadrant, and the second angle that we have is theta is equal to 5 pi over 4, whose position lies in the third quadrant. And so since our point 4, 4 lies in the first quadrant, then we're going to have our theta value to be pi over 4. And so now that we have R, now that we have theta, we can go ahead and write the following. We have our coordinate point 4, 4, which was given to us in x, y notation, and we were trying to achieve conversion to a polar coordinate r, theta. Well, from the exercise that we just worked out, we know that r is 4 square root of 2, and we know that theta is pi over 4, and this is the final answer. So in my next video, I'll go ahead and show you guys how we can go ahead and convert from a polar coordinate system to a rectangular coordinate system or the x, y system. It's a bit easier, and it's not as hard as rectangular conversion or x, y conversion to polar conversion. So until then, I'll go ahead and see you later, guys.